Good afternoon, everybody. Today we have Adrian Quesada Rodriguez, who will share with us a great topic, which are the implications of 5G and the IoT, comparing to the personal data protection system. We inform you that this project is created inside the framework of the NG-IoT EU project. And we have realized it thanks to the cooperation between the Istituto Italiano for Privacy and the Archimede solution, also with my colleague Pasquale Annicchino, who is now with us today. So I leave the floor to Pasquale and after to Adrian in order to start our webinar.
Many thanks, Alicia, and thank you for all those who are with us for this new webinar, which, as you know, is a part of a series of running webinars that we have done over the couple of last few months, basically. As you know, all the webinars are available on the NG-IoT website. They range from different topics which have to deal with, of course, privacy and security implications. And today we are very happy to have with us Adrian, who is an expert in this field and has been working on the relationship between 5G and personal data protection in some research project he will mention. So I'm very eager to listen to him. Therefore, I'm very happy to give you the floor, Adrian, and then we will see if there are some questions on your presentation. Adrian, the floor is yours.
Thank you very much, Pasquale. It's a pleasure really to be here with you, even if it's the distance given the situations. Yes, so as you have mentioned, my name is Adrian Quesada. I have been working in different capacities over the last 10 years in personal data protection, and particularly recently towards research-oriented activities. And I'm working with the IoT lab. So maybe I can start a presentation giving a quick overview of what the IoT lab is. I don't know if yes, perfect. Okay, so the IoT Lab is a Geneva-based international platform to grasp the future of the Internet of Things. We are involved in many different research-oriented activities, but basically our mission is to transform problems and ideas, particularly from the research projects, the European research projects, into something that is exploitable, that is has an impact on the communities, the economy, etc. So again, as I mentioned, we are a research and innovation platform. We have over 160 partners in 22 countries, and we have an ecosystem approach to IoT problem solving. This means basically that if we are presented with a particular situation, we rely heavily on the generation of a trusted ecosystem of partners that will identify innovative solutions to potential situations. We are always focused on generating an interface between research, industry, standardization, and the SDGs. We have a license status to the ITU, we have contact with key academic institutions, and we are members of the IoT Forum and the IoT Week. And as I mentioned before, we have a strong background in research, but because of our activities, we also perform activities as testbed. We have some services as well regarding IPv6 certification and some connection-oriented activities regarding, for example, the UDG as a service. So you can all see this range of actions in the IoT Lab site if more information is needed. The topic that I'm going to be talking today, the interaction between 5G, IoT, and personal data protection is highly complex. It's a topic that has been going on for for some time, and that will go or become more relevant the more time passes, because of the incredible change that 5G is going to bring for connectivity of the devices. If we look at the evolution of 5G, we have seen, of course, and this is something that's probably known to most of the persons that are going to be seeing this this webinar, we have the move from analog telecommunications to IP-based communications with 3G networks, and then we have Of course, 4G, where we have the current networks that we all enjoy, and 5G, which is what is going to be connecting us in the near future. 5G has a number of advantages over 4G networks, including, but not limited to, virtualization, which basically means that the same network can be divided into slices, which can be used for different purposes. We have the use of distributed big data processing centers for the virtualization of the infrastructure. We have a higher level of, or a denser network based on the capabilities of 5G and the need for more antennas, which basically means that the users will be closer to the networks. And as I will mention later on, this will also enable closer geolocation without depending on GPS and other solutions. And of course, the 5G networks include a range of security mechanisms to improve and mitigate the risks that this move from analog telecommunications to IP-based communications have brought. So we have everything from permanent user identified structure, we have encryption mechanisms, we have mechanisms to protect user data in radio interface, and general improvements in authentication and so on. These elements regarding 5G networks have been researched among other various Horizon 2020 projects in 5G PAGODA, which was one of the projects where we were involved, and which had the idea of generating or validating the 5G networks with between Europe and Japan. So we have both Europeans and Japanese partners, and to generate solutions to address critical issues, again, like climate action and secure societies through the use of 5G enablers. The main outcomes of the project, and I will again just leave the link in here for anyone who's interested, included among the technical some personal data protection related solutions, including deep data plane programmability system, which enabled the generation of traffic control quality of service to be performed on encrypted content based on an application level information. These are the kinds of actions that might be, I would say, small in the overall range or level of things regarding 5G, but that are a step forward in the state of the art, and that is related to research. Of course, with the advent of 5G networks, we have a number of personal data protection concerns. 5G networks are going to be adopted largely by both public and private networks. So everything from the network that every one of us has in their phone is going to move to 5G just to be able to profit from the increased connectivity. But also the private networks like banks, like automobile industries, IoT, will be able to generate slices for their own use cases within the same network without having to share or have problems with regards to the connectivity, thanks to the characteristics of the 5G networks. So this will bring a situation where basically IoT will be maximized upon its implementation. We will see a situation where all individuals will become end users of 5G networks. And I think that this is going to be in exactly the same manner as it happened with 4G. Basically, 10 years ago, everyone talked about 4G as the new generation. Now everyone's using it basically all throughout the planet. So this has implications from the point of view of personal data. The existence of a larger number of base stations, which are going to be closer to enable the higher frequency transmissions and higher bandwidth to be provided by the network to the end users or to the devices, is going to mean, as I mentioned, that we're going to be able to have a more precise user geolocation, regardless of the settings of the device that is being used. The fact that we have more data going on will mean that we'll have a higher range or higher chance for profiling and for automated decisions to be made, even if the network itself does not know the identity of the user, based, for example, on the metadata, the transit data, and so on. The network will eventually have to do some automated decisions, for example, base minimum of who gets more or less bandwidth, or these kinds of situations that sometimes happen in different contexts, I would say. The fact that we have more stakeholders, because in the 5G networks, we have a situation where, for example, a network provider, the traditional network provider in the past was the one that handled the whole range of the communication. They would be the owners of the servers, they would be the owners of the antenna, they would be the owners of the software that was running the whole system, and they would hopefully, or in most situations, also provide the end user with the devices, the phones, or whatever element was needed to connect to the network. In a 5G network, given the fact that we have the potential for virtualized networks, we have not only a disconnect between, for example, the owner of the network and the provider of the infrastructure, because, for example, you can have virtualized infrastructure that is run from a server in California, and then we can have another piece of the infrastructure that is run from China. This basically brings in diffuse responsibility, where, again, manufacturers, network operators, service providers, they all have different privacy goals, privacy requirements based on the jurisdiction they're in. And generally speaking, they suffer from the lack of homogeneous security models or standards. So this again provides or brings a tricky situation for data subjects. The fact that we have more services, again, this is a basic element of the evolution of the internet. Things change, the increased connectivity, interoperability, the increased numbers of input points, management points, they are all elements that can be exploited by malicious individuals to basically generate cyber attacks, to generate data breaches. So this is a legacy issue, I would say. This is something that has been, or that is common to basically all kinds of communications, but that is even stronger in the context of 5G networks. We have, of course, more virtualization, which brings in potential vulnerabilities based on everything from APIs, different levels of contractual decisions between the parties, and so on. And we have, of course, more data flows, which basically mean the potential for a loss of controls by data subjects. The situation regarding 5G networks is, again, as I mentioned, really interesting because of this balance in the potential that it brings for connecting an insane amount of devices to the network without losing quality and without affecting, I would say, the bandwidth or the capabilities of the end users. This connects directly with IoT. The evolution of IoT, and I think, the evolution of IoT, as we have seen in the previous years, has been immense. We are looking into a gigantic number of connected devices. I think 75 billion devices are expected to be generated or to be available by 2025. And IoT is, as a platform, I would say, or as a concept, is something that is really close to the data subject. The IoT elements or the IoT things are highly complicated but really simple devices at the same time, in the sense that they are generated or they are created en masse, and then they suffer, or they can be I would say that they can be incorrectly managed in a really easy way because of the fact that they are generating generated to be cheap and to be easily accessible. There's many attack vectors or potential vulnerabilities in there that can be affecting IoT. So if you look at 3 typical use cases where this situation can bring complexity and can bring, I would say, some difficulties from the perspective of personal data protection. Of course, the first one would be consumer IoT. And in here, what we have is the typical smartwatch, the typical smart speaker, or any kind of other consumer component that is available and that nowadays most people and most, I would say even some kids are playing with as a normal basis. We have devices or things that are supposed to be or are everyday objects and that are becoming smarter by connecting to services, to software, or by being integrated in this way through various networks. And of course, right now, most IoT, and particularly consumer IoT, does not directly connect through 5G. That is, I think that is, I would say, for the moment, mostly used for other uses, industrial IoT and so on. But as the networks become available and the technology becomes cheaper, I would say that it's just a matter of time for this to happen. So we have constrained and non-constrained devices. Constrained devices being devices that are simple, that are cheap, that are easily hackable, I would say as well, because of the potential for vulnerabilities. And non-constrained devices, which could be your computer, your smartphone, and so on, that are going through the same networks, that are highly related to the provision of services to the data subjects, to the individuals. And then we have a situation where you have associated services, basically the services that are core to these devices, and services provided by third parties. And all of these services depend basically on the fact that the device is going to be sending in information from the data subject to the services. This information can be personal data, can be technical data regarding the status of the device, but most of the time for a smartwatch or a smart band or something like this, basically we have a collection of sensors that are going to be constantly providing information regarding the data subject to the network. And then, as I mentioned before, we have both the core services that are expected. So for example, if you have a smartwatch, you will have the smartwatch which provides you the very basic capability of seeing your status of how you slept or whatever. But then you also have some services that are provided by third parties, and those services might not be directly disclosed to the data subject. So in here we have, of course, a concern because it's you have a potential for loss of control. The main problem with consumer IoT at the moment, and as I mentioned, especially as we get more 5G connection enabled devices, we'll probably see this more, is the fact that they are deployed outside traditional IT structures. So if it was generated or if they were deployed inside of a company, for example, usually the IT team is going to take care of ensuring that the device's firmware is updated, that the ports are not available for malicious users, that the devices are not taken out from their locations. You will have the whole process. In the case of end user consumer IT, most of the time you just have a device that is left that is situated in your living room or whatever, and then you just ignore it until you have to throw it out, or you use it normally, and then if the manufacturer pushes an update, maybe some users were going to be carrying out that update, but most of the users, from what I've seen, will just try to ignore it or make it go away somehow. Then you have the situation where, as I mentioned, these consumer IoT devices are generally speaking made to be as cheap as possible. And then this has limitations regarding their capabilities. They are usually lacking security. So given the cheap and the low power characteristics of these devices, they are not able to perform, for example, data encryption. They are not capable of processing data locally. They have to submit just all the information to the network for the manufacturer or the service provider to actually do the processing. And the fact that these devices usually manage sensitive data. So again, if you have a smart band, it will measure your heart rate. It will do many different activities that generally fall within the concept of sensitive data from a data protection point of view. On this perspective, I would say, and I'm sorry I didn't explain this before, but basically I would like to bring to the attention of everyone who's watching the fact that there's different research-oriented activities which have addressed these points in various ways. I would say that one of the relevant research activities that are happening right now is Fed for Fire, which is the largest federation worldwide of next generation internet testbeds. It's basically a project aimed toward enabling research and experimentation in Europe, and which has the capability of mixing or enabling researchers to focus on the interconnection between different networks and different devices with capabilities. So the research that Fed for Fire enables is particularly relevant for consumer IoT in the way, or in the fact that it enables, for example, a new company that is willing to generate or to deploy IoT to perform assessments on whether it is feasible to deploy it safely, for example, or feasible to push updates to devices in a way that is simple, that is doable. The second use case that I think is relevant to this discussion is the discussion regarding industrial IoT. And this, I'm going to focus mainly on smart buildings, again, because of the connection with research activities that we have undertaken in the past. In the case of industrial IoT, you have collections of hardware and software, again, that are embedded in the buildings and or in tools, and that are, generally speaking, focused on non-personal data processing activities, but they also have the potential for processing personal data. So a typical smart building, for example, will have temperature sensors, will have occupancy sensors, will have the AC system, will have the fire system, will have security, and so on. And again, the situation is that all of these things are normally carried out through a network that is not 5G based, but as 5G becomes more available, it will be simply easier and cheaper for deployment in a smart building to connect to the network that is already available and that is easily accessible from anywhere in the building than to run the cables or to run a local network and so on. So again, the situation is that even in the context of a smart building, the interaction of relatively cheap, relatively low-powered devices with the wireless radio channels brings in potential vulnerabilities. So again, the personal data that are processed by the smart buildings are usually, I would say, aggregated. In most cases, you don't necessarily see a situation where a smart building is controlling room by room temperature or recording specific elements per se. But you also have situations where you have, for example, cameras placed for security reasons and so on. And the key concern when it comes to this use case is the potential for multiple databases available to be mixed together into bringing in something that was not personal data and turning it into personally identifiable information with a relative ease. So if you think, for example, about a smart building that has all of these sensors and that has all of this information, and this information is not processed locally, but is, for example, sent through 5G networks that are virtualized to a service processor, service provider, then you start to see the potential complications, because as I mentioned before, the service provider might not be within the same jurisdiction, might not have the same security standards. And when it comes to corporations, to organizations that are different sizes and different have different organizational structures, it is really difficult to perform basic activities that are necessary for maintaining a correct personal data protection framework. You have, of course, the risk of misunderstanding the security of the systems that you're providing, because, for example, a company might include security cameras to increase its security, but maybe it's generating potential risks because of the fact that it's including these cameras that are sending in information through the network. You have the risk, for example, of an oversimplified view by the technical team of what they're implementing, because sadly you have a disconnect between what is recommended from a technical perspective and what is necessarily or required from a legal point of view. So maybe if the team that is implementing these systems, it does not have a holistic perspective, then you might have an oversimplification. And again, for example, in the case of, I would say, for example, occupancy sensors, you may say it's all pseudonymized because it's all aggregated, but maybe it's not the case. And then you have, of course, the difficulty of bringing in the personal data protection measures and turning them not only in the rules and the mechanisms that are necessary from an organizational point of view. A company might say, okay, we need to protect the personal data of our customers and of our personnel, but then there might be a disconnect between those rules and the contractual mechanisms and the technical implementation. Maybe the team in charge of negotiating the contractual mechanisms for the service providers do not include the whole range of controls, or do not include the whole range of elements that are necessary. Or it can be back into the organization. If they don't have enough rules to ensure that personal data protection is protected at every level, then you have potential risks. So again, these are elements that I would say are outside of the realm of pure 5G, but that with this interconnection, they become quite more tricky. And I would say that one additional element or one additional difficulty is how to inform the organizational stakeholders about the reality of the security and the personal data protection status of the organization. They would, okay, most manager level personnel will not think too much about the networks that they're using to connect to their systems, or the networks that are being used to connect to their security systems as well. But there's a need to bring that information down into something that is in the mind of managers and for personnel in general, because personal data protection is a process that needs to be followed throughout the organization. So bringing this back down to Horizon 2020 research activities, I would say that one associated research project that is of high relevance, and again, it's available for anyone to see, is the ANASTACIA project. This project was terminated, it finalized the beginning of this year. And it was focused on the generation of a solution that enabled trust and security by design for physical systems based on IoT and cloud architectures. The key element in which I was involved for the personal data protection perspective is the DSPS, which is the dynamic privacy and security seal. And this seal, sorry, because you can only see it barely on the corner of the screen, was an enabler that we designed to try to bring in a graphical representation of the security and the privacy status of the network, the cyber physical systems and the IoT devices inside of a smart building, and make it easily accessible for a manager, for cybersecurity specialists to see. And it had, amongst many advantages, some blockchain integration to enable historic log of this status and so on. The third use case that is relevant in this context is, of course, connected vehicles. And this, I would say, that is a little bit of a gray line between consumer IoT and, I would say, a little bit more industrial IoT, in the sense that, yeah, your vehicle is connected in different ways. Connected vehicles, for these purposes, we don't just think about the self-driving Tesla that is being used right now, but any car that has some sort of connectivity, that has sensors, they have implications, or that they have potential for becoming connected to the networks, and which can bring implications for personal data protection as well, of course. So you have a multitude of sensors in most modern automobiles, but of course in taxis and buses and all kinds of public transportation, that is being interconnected, again, for now, through normal or to other networks, but increasingly through 5G dedicated networks. And these devices, or these vehicles, are generating many types of data. They are generating the technical data regarding how they run, and also the personal data, for example, regarding the infotainment system, the preferences of the users, the way in which the user drives, and so on. All of these things are being stored for different users, everything from, for different use cases or different purposes, everything from entertaining the user, enabling the reconstruction of accidents, for example, for security logs, and the generation of tailor-made insurance rates. So the situation is that we have a great amount of personal information that is in the vehicles that is not always evident to the person that is driving, that this information is being generated, compiled, and then shared. And you have concerns, of course. What is the purpose of the collection? Whether the information is shared? Where is the processing location? And whether the end user is being informed. These are all elements that have to be addressed when it comes to the deployment of connected vehicles, and particularly in the context of a 5G-enabled vehicle-to-vehicle communications. But basically, we have the sad reality that the vehicles that we're driving, despite being for all purposes basically IoT devices, they are prone to denial of transmission, reception of data attacks, modification, deletion of information, and so on. They have many risk or attack vectors that are possible, that make them I would say a concern for the data subjects. In this context, again, and doing a little bit of information, we have the 5G Drive project. It was a Horizon 2020 project that was focused, that is focused on the interoperability between EU and China 5G networks for V2X, vehicle to everything scenarios. So 5G Drive has developed several interesting solutions for enhancing personal data protection within the context of connected vehicles, including the generation of situation-centric dynamic pseudonym changing strategies for software-defined networking based 5G systems, and a model for deploying vehicle location privacy zones in smart cities. So these are just two of the solutions or the ideas that are being examined right now by Horizon 2020 projects to try to increase the trust, potential for trust in vehicle-to-vehicle communication, but generally speaking to enable the better protection of personal data in these use cases. A second relevant research, I would say, is from PLATOON, and this one actually relates a little bit more towards the industrial IoT. PLATOON is a Horizon 2020 project that aims to develop and use reference architecture for scalable and replicable energy management solutions. And again, as I mentioned, PLATOON does not necessarily focus on 5G connected infrastructures, but it is generating solutions that build upon industrial IoT and particularly smart building IoT deployments to generate approaches that are compliant with personal data protection requirements. So going back to the general IoT concerns that arise in this context, you have a situation that is quite simple. You have the gigantic number of deployments and devices of IoT versus the requirements of the relevant legal framework. In the case of Europe, we're really lucky, I would say, because of the fact that the General Data Protection Regulation has a strong, or I would say one of the strongest requirements, or set of requirements in the world right now to provide security and trust to the data subject. In some other countries, they're not as lucky. And the main problem comes when it comes to deploying IoT or to managing IoT. And in every one of the use cases that I mentioned before, you have the need for an increased connectivity versus the fact that you also have to comply with requirements with this principle. So you have the principles of lawfulness, fairness, transparency, purpose limitation, data minimization, accuracy, storage limitations, integrity, and confidentiality. And these are all encompassed by the personal data protection by security and security by design and by default approach. So how do you actually manage to do this? You have a number of requirements that need to be implemented, but it's still, I would say, a little bit tricky, particularly in this kind of converging context, to understand how to implement these principles, these requirements into an actual 5G enabled IoT deployment. So going back to the concept that I just mentioned, the personal data protection by design by default, this comes a little bit from the past, from the concept of privacy by design that was originally postulated by Ann Cavoukian, and which was based on 7 foundational principles. She seeks, or her general idea was to generate a system, or basically that any kind of system that would process personal data would be proactive, not reactive, would be preventative and not remedial. So basically that the approach would seek to protect the data subject in advance and try to avoid potential implications to the rights and freedoms. Privacy as the default. So this one is a really tricky element to find because of the fact that if you consider, for example, IoT devices that are connected to 5G networks, the basic functionality that they provide is privacy invasive, I would say. So you have to find a middle point in there to enable the control of the data subject, of the information that's being transferred and how it's being processed, without counter or affecting negatively these principles. So the idea here is that, in theory, and based on what the GDPR requires as well, you would not need to opt in to have an enhanced security mechanism in place, or personal data protection mechanism in place. Then you have, of course, the idea of privacy embedded into the design. And this is something that is quite tricky to implement. And as I will see, I will mention later, this means that the whole process of designing the IoT devices need to be done through close attention to personal data protection concerns to ensure that the maximum security and personal data protection measures are in place. Full functionality, so basically that if you get a device that is aimed to measure your heart rate, these functionalities should not be affected negatively because of the fact of the increased personal data protection requirements. Then you have the end-to-end security, and generally speaking, visibility, transparency, and respect for the user privacy. So these were the original concepts that Ann Cavoukian formulated. The implementation of these concepts is, again, quite difficult, I would say, in most IoT scenarios, because of the fact that you have to consider technical, contractual, and organizational measures. You have to minimize personal data, hide personal data, metadata, separate processing and storage, aggregate, inform, control, and all of these elements that are relevant or that have to be considered when it comes to implementing an IoT deployment. And you should be able to do this also in consumer electronics, or, for example, in connected vehicles. So what are the actual implications of this situation? Well, the situation basically brings us back down to a greater complexity for regulators. Again, as I mentioned, in Europe, you're really lucky because of the fact that the GDPR is quite strong, but then you have a situation that is intrinsically transnational, and in which, sadly, not every country has the same capacity to introduce legislation that is up to the speed of the technological development. Then you have the increased risk surface for data subjects, and you have varying levels of control of devices. Basically, this means that in every single one of these use cases that we have examined before, you have a diverse set of potential risks that can happen with different type of personal data that can be affected. Everything from more or less aggregated data in the case of smart buildings, down to highly sensitive personal data in the case of the consumer devices. And then as well, varying levels of control over the personal data protection preferences in those devices. It's much more different to have all of the control centralized in, for example, a solution like the DSPS, or a solution that is managed by an IT team in a smart building, than it is to have to somehow manage to inform about all of these principles and how it's compliant, how the devices are being compliant in the case of a smart teddy bear or a smart vehicle. Hopefully you will have a screen or some way to connect and to convey that information, but it's not easy. And if you're trying to convey highly complex information, you also have to think about how to easily showcase why it is necessary that your smart teddy bear needs to connect to a server in, I would not say in another country to be able to provide you with their services. So this brings us down to the fact that in 5G, you have this globalized and distributed processing and infrastructure. You have an increased risk of international transfers of data, be it risks of international transfers that are consented by the data subject and data transfers that are not done with its consent, because of the fact that the devices themselves and the networks, each one of them will have maybe different security policies in place and different personal data protection laws to report to. And again, from a more legal point of view, you need, or it has brought the need for clarity regarding how data protection authorities are going to be cooperating on the implementation of the geographical scope of the GDPR. So how are we actually going to bring in cases where you have international transfers of personal data, and how you're going to be able to pursue potential infringements outside of the European Union, for example. Out of the research activities that we have mentioned in the different use cases, there are a couple of recommendations that can be raised. So for IoT, it's highly important to have clear and transparent information about personal data protection. You have to have valid informed consent. You have to have a method to manage and to enable the withdrawal of consent. And you have to have data minimization in place to account for the fact that the devices themselves will not necessarily be the most appropriate to handle the data that you're entrusting onto them. Then you have, of course, the need for trust. In the end, all of these elements are aimed towards enabling the data subject to trust the deployment or the system. It's a similar approach for the 5G networks. You should have security in place to ensure that the security that is being used is a place that you have encryption, that you have interactions that are done through tunneling or through HTTPS or TLS and so on. Then you have the need for data localization. If you are a company that's deploying a 5G network, you are going to have to account for the possibility of maybe not having the infrastructure be virtually processed in a server in Madagascar or China or one of these places, but maybe it has to be done in the local country so that it's subject to the same legal obligations that the rest of the system is. You have to specify trustable transborder transfers. You have to specify or to determine the data ownership, and you have to have control over the infrastructure, be it virtual infrastructure or not. And in the end, you have to have a way to convey this information to the end user so that there is trust that enables them to properly use your networks. So these are some recommendations that have arisen out of the research activities. And of course, you have more general data protection related actions. I'm not going to go through all of them, but each one of these elements need to be considered by a deployment, an IoT deployment, particularly when it comes to mixing these two realms, I would say. And then we have, of course, some new actions that are aimed toward enhancing the minimum level of trust that is available for IoT devices. You have actions. So for example, Etsy has just released the standard on cybersecurity for consumer Internet of Things, which provides baseline requirements that are quite close to the elements that we have mentioned in the previous slides. Then you have, of course, the need, as I mentioned, to provide trust to the data subjects, and this can be done through certification. So we have two, I would say, of the most relevant developments recently. The first one is ENISA's Common Criteria-based European Candidate Cybersecurity Certification Scheme, which is currently open for consultation. And it provides a really interesting view on cybersecurity certification in a way that hopefully will bring some baseline to cybersecurity that is accepted throughout Europe in the same way. So if this were to be implemented in 5G enabled IoT, I would consider it to be definitely a win. But this is, of course, cybersecurity. On the area regarding personal data protection, you have a quite trickier situation. The GDPR Article 42 includes the possibility of the existence of certification, but for the moment, there's still a little bit of elements that need to be clarified on from the European Data Protection Board to address these issues properly. One of the options that are right now on the market and that will hopefully be approved is the Europrivacy GDPR certification, which I have to mention the fact that I'm in the board of experts of Europrivacy, but we have developed this in the context of various Horizon 2020 research projects with the goal of generating an European-wide GDPR certification that encompasses all of these technologies and that is capable of addressing all of these requirements in a way that enables companies, enables organizations, and in the end enables data subjects to have trust on the devices and the networks that they are going to be using. So I will leave it at this. I don't know if you have any particular questions, Pasquale. But this is my contact information, and in case any question arises, I'll be more than happy to address them.
Alicia, if there are no questions, you have the final word here.
Yeah, thank you, Pasquale. Thank you, Adrian. I think it was a great webinar today, IoT and 5G related. So I'm really happy to have the possibility to share all this information today. So thank you, really, thank you very much. It was a great work. You are doing a great work, I think.
My pleasure. Thank you very much.
Thank you. Bye-bye.
Thank you. Have a good afternoon. Bye-bye.